Okay, wow, it's December 7th. It is our last day. So there's a file to download for today. This is a portfolio optimizer. This is an example that is actually really, really well developed. We're just going to kind of add on a small part to this largely developed system. It's actually an example that I used to use years, can I say now, more than a decade ago, was like an example that we would kind of build on and for multiple examples throughout the term. And I've kind of moved on from that, but it's still a really good example for this particular day. So let's go ahead and just get that workbook open. We'll talk about what it currently does, and then we will see what we're going to do to change it. So I've got that open right here. And so the idea here, in fact, so part of this was teaching about user forms. And so there's this add tickers thing that just brings up a form with, some various things on, but all it's really doing is giving you a list of tickers right here. So are you sure? Why, yes, I'm sure. So, this then is the set of tickers that we're going to be using in the model that we're running with here. And our dates are, these are the dates that we're going to collect data for. So the idea here is that we want to build a portfolio of these tickers. And the question is, given the assumption that those are the tickers that we're going to buy, how should we allocate our portfolio? How much of each stock should we buy? And so, what percentage of the money that we're going to spend on this should go into American Express? What should go to Apple? What should go to Ford? And the question is, how are we going to decide that? So we're going to look at we'll just go through these sheets. So what Consolidate does, so they get data here, we'll actually go through and bring the data in. Don't click it because it takes a while to run. And if you all clicked it, you'd outrun what this particular key allows you to bring in this current data with. But we've already got the data here that we need. And so what these are is that this is the monthly percentage change in the value of each of these stocks. So this is like month over month for the period that we've said, how much did this change? It went up, it went up, it went up, it went down, it went up, it went down, and so forth. So this is going to kind of show us, what is the volatility of this stock. If we average that, we should see what the average monthly change is in that stock's price. And so this summary page just does that. Like this is summary measures for stock returns. Yeah, so here's the means of these. And then I think this is the standard deviation. Yeah, so this is going to be the correlation, kind of how these stocks correlate to each other. So of course, when American Express goes up, it's like perfectly predictable. Where's kind of a high correlation here? 0.4 is kind of high. Here's a 0.5. See anything higher than 0.5? So this says when Oracle goes up, ExxonMobil goes up. So they move together, pretty good. Like I don't know, maybe half of the variation in one is explained by variation in the other. And so that gives us some information about how these stocks, move together, or, do we have some that are negatively correlated here? Anything negatively correlated? No. So when they're going up, they're going up. When they're going down, they're going down. And so this then is the model that we want to be able to optimize. So this is kind of set up to say, listen, here's those same set of stocks that we had there on that front page. And right now they are allocated even. So there's 10 stocks here and 10% of our portfolio is going to each one. And so this then is the expected return for each one of those stocks that we get from that historical data. So that's our kind of our best guess about what the expected return is going to be. And what we're trying to do is we are trying to say, listen, in this, we want to say, I want some expected return for this portfolio. And for whatever that expected return is, I want to minimize the volatility of the portfolio. So I'd like to be able to say, listen, I'm not trying to get, what's the highest expected return that I can expect out of this portfolio? Now look at these numbers and tell me what's the highest expected return? What's the highest return I can expect from this portfolio, given the assumption that past data is going to predict future performance? Yeah, I asked that question. I don't know the answer. Which column are you looking in? Apple and Ford. So Apple, so like a 10-point, that's a 1.6 monthly increase. And at the highest one, 0.01 and 0.24. So yeah, so what if I'm saying, listen, what I really need here is a 0.02404 return. That's my expected return. How is this thing going to have to allocate? I'm going to have to put all of my money into that stock, right? That's the best performing stock. That's what I'm going to do. But if I'm saying, listen, no, I don't need that much. I could get by with 0.01. That would be enough. And so the question is, how could I get that expected return out of this portfolio with the minimum volatility? Like I want to minimize the risk to be able to get that expected return. And so if I look at the minimum return, maximum return here, what's the expected return? Constraint on return. Here it is. So this is the sum product of those expected returns and how they're weighted here. So this is going to be the expected return of the portfolio. And then I'm going to put a constraint here that says, you know what? If we look at this, oh, look, that is the highest one right there. So if I was to optimize with this constraint in place, it would dump everything into Southwest Airlines. But if I bring this down to something lower, 0.01, then it's going to give me a different allocation, if I can get Solver to do that. So tell me, just kind of show me on a scale of 0 to 5, how comfortable you are with Solver. I'm using Solver. So I'm seeing 4s, 5s, 3s, 2s. Okay, so basically it looks like everyone who's voting is telling me that you at least know what Solver does. And so this class isn't so much about, explaining what Solver does. I'm not even sure I'm the right guy to talk about really under the hood what is going on when Solver does what it does. But how could we optimize that? I'm sorry, how can we automate that? And what's interesting here is that if all I'm changing is like the parameters of my model, then I can set up the Solver model and I can change the parameters. There's no VBA required. Where VBA becomes important is we say, no, I've got to change the structure of the model. So in other words, this basket is going to have 10 stocks this time, but I'm going to run it again with 150 stocks. You don't have it optimized a very different size. And so it's going to have to rebuild that model because the constraints are going to be different. So if I'm just changing the values of the constraints, then no VBA necessary. But if I'm changing which constraints are happening and I want that to be automated, that's what we're looking at doing. Okay, so let's just go ahead and build the model by hand first, and then we will record ourselves building that model, and then we'll see how to kind of integrate the code that it generates. So I'm going to come to the data tab, and I should have Solver installed right here. Now, you may not have Solver installed. Is there anyone who's coming to their data tab and they're not having Solver show up? We can go through, it's pretty quick to install. No one, so it looks like you've all got it there. Excellent. So I'm just going to open up Solver. Okay, and so the main thing that Solver is going to do is it's going to try to achieve some particular target cell. It's either going to say, listen, I want to maximize the value there, I want to minimize the value there, or I want to get that as close as possible to some target value. And so in this case, what we want to do is we want to minimize the portfolio variance. Like we want to minimize the volatility that we're going to expect in this basket of stocks. And so I'm going to set my objective cell to this portfolio variance. So that's D12, and I want that to minimize. Now the cells that we're allowed to change are the weights. So by changing these weights here, that's what you're allowed to change. Subject to these constraints. You can't just go crazy, because if we're trying to minimize that, how could we minimize, if that's all we're trying to do is minimize the variance, what could we do? Yeah, just put 0 on everything and you'll have 0 variance in that portfolio. No risk. Super. With some constraints here. And so we're saying, you can't just run that all the way down, because what we're looking for is we're saying, no, listen, the expected return from the portfolio, whoops, let me go get off that cell as I'm pointing around. What we're saying is that the expected return on the portfolio has to be at least as high as our required return. And that's what we're marking right here. So I'm going to add that as a constraint. So I'll come over here to constraint. We'll say add. I'm going to say that cell has to be greater than or equal to this cell. And I'm going to add that one. Other constraint that we're going to have is that my sum of weights needs to be equal to 1. So that's just the sum of what all those weights. We're going to allocate the whole basket. So I'm going to make that one. Sum of that is exactly equal to 1. Make unconstrained variables non-negative. So that looks good. So we're not going to put anything negative in this. It's got to be a positive number. And I think that's all we have to do to make this thing optimized for us. So I'm going to go ahead and solve this. It says solver found a solution. That looks pretty good. And I'll say okay, and we'll just take a look at what it did. So in this case, it says, yeah, so it's found us this slightly higher than my required return. And it's saying, yeah, I'm going to put 7% here. I'm going to put 12% in Oracle, 11% in Microsoft, 27% in cost. Is that Costco? That's Costco. Going to go invest in Costco today, I guess. And so that's how it's saying. It's saying, to do this, we're not going to put any of this into Southwest Airlines. Okay. Now, so the whole idea of solver here is, well, what would this be if I said, no, I need a little bit more than that. I need 0.015. And I should be able to just open that solver. It's still configured, just solve it again. And that's going to give me a different allocation. So to be able to get that, I'm going to buy some Southwest, no more IBM and GE. That's the idea of the model. So what we'd like to do is we'd like to see what do we have to do to kind of automate this process. And there's some things that are a little bit strange. Now, how many of you at some point where you've looked at the VBA code that's been recorded, when we recorded something and you went, wow, that was a really weird way to do it. Yeah, I wouldn't have expected to do it that way. You had that experience, yeah. So I got to tell you, Solver is an add-in. It's not written by Microsoft. Who writes Solver? It's a company called Frontline Systems. So it's just some other company. My guess is they give Solver to Microsoft to include because in the world of like optimization, the solver that comes with Excel is the kiddie pool. And if you're doing something that's really serious, you're going to need to get a different add-in to do that. And I guess the guys at Frontline hope that if you're using their one here, that you'll pay for their more advanced add-ins that do optimization in Excel. But the point is that now we've got a different company who's actually doing the macro recording part of this. And so some things that like if you thought Microsoft was strange, there's going to be some weird things here. And it's going to feel a little bit different just because it's a different company that's like making the code. Is there a question here?
Is this principle of how we're optimizing with weights kind of how index fund works?
So the question is this principle of like how these are getting optimized, is this like how an indexed fund works? And I don't think it's how an indexed fund works. So an indexed fund, I am not a finance professor. My understanding of an index fund I probably got from the finance class I took in the early 1990s. But an index fund is like, we take an index, like the Dow Jones, and we just say, we are going to buy kind of proportionally to the market cap of that anyway. Yeah, there are many of you in this room who can answer that question much better than I can. This is a really, really, really simple model that says, how are we going to allocate stocks? Like models that people are really using are dramatically more complex than this. Okay, so and when I say people, I mean professional investors. They're not just because this doesn't say anything about which stocks should be here. This says, assuming we have these stocks, how can we allocate these to minimize the risk to achieve that return? Now, so the point is that right here, I could achieve this same return with lots of different allocations here. But in order to do that, I'm adding volatility to get that. So that's what we're kind of achieving at this point. Ultimately, what we want to do is we want to say, listen, let's not just take one picture of this, but let's take 11 pictures of this. Let's kind of move the required return from a low number up to a high number and be able to generate what we might call the efficient frontier. That's what this chart will do. Kind of once we get this kind of filled in, where we've moved the required return from something low to something really high, this chart then will kind of show us what that efficient frontier looks like for this portfolio of stocks. Okay, but now I think we're ready to go ahead and record ourselves configuring this solver. Okay, so I'm on this page and I'm going to start recording. So my developer tab, record macro. I'm going to call it macro 1. That's fine. We're just going to get it so we can get the code, and we'll be cutting this code and putting it in different places. I'm not going to give it a shortcut key. I'm just going to record. All right, so to my data tab, over here to solver, and I'm going to start by clearing this all the way out. Is there a clear here? Reset. Reset all. There it is. Thank you. I am now 54 years old, and it is time for me to get bifocals so I can read this screen and still be able to see you. I have a sense that that is my wife's gift to me for Christmas, is bifocals. It's a really great Christmas gift. All right, reset all. You want to reset this stuff? Yeah. Okay. So, and that step is important. To reset is important, because what we're about to do is we're going to come and add these constraints. What constraints are going to be in this model when this macro runs? We don't know. Like, whatever the user might have set up before, that's going to be there. So we want to say, hey, we're doing this from scratch, reset everything, and then let's bring in the new model. So we'll go through that same process that we did again. We'll set the objective cell as our variance. We're going to minimize that by changing the weights. We're going to add 2 constraints. One is that the constraint on return must be greater than or equal to the expected return. I'm just going to say add here rather than saying okay. Okay would kind of take me back to the other dialog box. Add will just add that one in and leave me right here. My sum of weights needs to be exactly 1. And the rest of these should default. That'll be just fine. I'm going to say solve. I'm going to record myself solving. And I'm going to say okay on that, and we'll stop recording. And let's go take a look at the code that we just recorded. So under modules, so module 1 is the code that was here before. We're going to be integrating into this code. It's quite a bit of code because the project does quite a bit. I mean, this really will, you set the tickers, push the button, and it will kind of push this whole example through. In fact, was it this one? Oh no, it was funny. It was a different one. But when I applied for this job in like 2006, I had an interview with the deans, and I'd been teaching this class, programming in VBA, for a few years. And I had a student for their final project. At that time, I used to do a final project instead of a final exam, and had a student that was had done a really interesting final project. He had done kind of automated a complete Venn gram analysis. When I say a Venn gram analysis, how many of you go, I know what you're talking about when you say a Venn gram analysis? So we did one little part of a Venn gram analysis when we did the Fallen Angel report. So Venn gram was like one of the pioneers in kind of looking at financial ratios to understand where to invest. And so Fallen Angel was kind of one of the things that he would kind of piece of information he would use to decide who to invest in. And there was like 10 of these. And so, I was interviewing with the deans, and it kind of showed them, oh yeah, they were interested in this class because they'd like to start teaching it here at BYU. And I kind of brought this project up and showed it to them, and they're, oh, that was really impressive. 2 of the 3 deans after that contacted me independently. Hey, could I get a copy of that workbook that your student did? So I guess they wanted to use it for their own personal investing. I don't know. So kind of similar here. All right. What do we know? Oh, we're looking at what got recorded on module 2. Okay, so here then is the macro of us that we just recorded. So no surprise here. The first one is solver reset. And let's just look through this before we try to integrate any of it. Okay, so now we've got a sub procedure or a procedure here called solver OK. That's what it's called. This looks pretty good. Set cell, that's the cell that we're setting. Min max val equals 2. What do you suppose that means? What do you think min max val gets assigned to 2 is? Yeah, 2 must mean minimize, right? That's what we did for that. Value of probably only relevant if we set it to whichever one of these is for going to a value. By changing, so here what we'll see is that we got by changing that range. This is kind of an important thing to change. Now, we probably should modify this code so that it figures out what that range is, instead of just having this hard-coded. Well, good news. If you'll look here, the code that actually generates this sheet and all of this from the tickers page has to be here, but everything else will get generated when you kind of run the full thing. But you'll notice the code that does this actually names this range weights. And so we can just change that to weights. So now it will use that named range. And so when the code changes how big that range is, when this runs again, it will pick that up. So this isn't going to do our constraints, but it's going to set the main parts up of that. Then we get solver add. This looks pretty good. That cell reference gets a relation of, so 3. So this must be greater than or equal to. 3 must mean greater than or equal to. And then formula return is that particular range. Now this is interesting. A named range is going to work okay here as a formula. And here's kind of one of those things that's weird about this, that this won't work with just a single integer value here. This needs to be a formula. So I've got to actually change that to say equals 1. It took me hours to find that out the very first time I was trying to find out why this code didn't work. But that formula text needs to be a formula. As a named range, that works okay. So I guess another option would have been for us to name this range and let it go, but it can't just be just a 1 by itself, and change that to a formula as equals. And so here we are then adding our 2 constraints. So relation 2 must be equal. So that cell has to equal 1. This one has to be, D10 has to be greater than or equal to this one. Now, what's this? Solver OK. Is this different at all from my other solver OK? It's different because I changed it, but I think it's the same as it was before. Why does this one get recorded? I don't know. Why does the next one get recorded? I don't know. So we'll get rid of those. And then this one, solver solve, this is the same that actually says go tell solver to do its stuff, but it takes a parameter here. And the parameter here is user finish. So this is binary, it's either true or false. So what do you think? If we want that to close, I don't want the user to have to close it. I want that thing to close automatically. Don't even show that thing. What should we put? True or false? User finish true. User finish false. Yeah, that's exactly right, because I think it's backwards how I would have expected it. Because I think user finish, I want to say true, let the user finish this. But I think it's false. User finish false. Well, I'm going to put false. I can't remember. If it actually shows that, we'll change it on the next time. Okay, so in fact, we could probably run this now. Reset, it would populate it. Yeah, let's go ahead and run that now. We're going to make sure that the model sheet is active. And I'm going to change the required return back down to just 1%. And we'll run that again. I had it backwards. I thought about it and still got it wrong. So we'll change that to true. And run it again. And then it optimizes it. Change it one more time. 0. 1.8. Run that code, and we can see it change again. Okay, so that's like the basics here, but let's go ahead and integrate this into this example and kind of build this the rest of the way out. Okay, so let me just kind of come back and look over the existing code here in module 1. So I'm going to come to the very top and let's see. So this is going to show that form, get data, build model. Okay, so it looks like build model is like this is the main procedure that controls everything. That's a great note that we've got here. So it's going to run summarize, and then we've got this config solve. Then we got these three. So summarize gets the data into the right place. We're going to have to set up config solver, run solver, and find frontier. So here's config solver with nothing in it. What do we want to put from this? What do we want to put in config solver? I think for config solver, we want this. So this is what's going to build the model. So I'm going to take that part. I'm going to put that inside of config solver. I'm going to do one more thing here on config solver, and that is anytime I'm working with a solver, it assumes, which, by the way, how many solver models can I have in a workbook? Can I have more than one solver model in a workbook? Yes, I can. I can have a solver model on each sheet. And so it's not enough just to say, hey, I want to change the solver. I got to tell which of all the models I want to work with. And the way the code works is the way you tell it which one to work with is by activating the sheet that has the model you want to manipulate. So when you say solver reset, you're not resetting all the solvers. You're resetting the solver on the currently active sheet. So we are going to make sure that is the active sheet. What's that sheet called? It's called model. So this workbook, got worksheets. Oops. The one called model dot activate. So, for me to be able to configure that code, that has to be that model, that has to be the active one. And I'll need to do that same thing when I run it. When the solver gets run, that has to be the active one as well. And I'll just go ahead and bring in the statement that's going to do the running. Solver solve true. So that should then run. Oh, it looks like find frontier is already built out. So what find frontier is, it's going to figure out, it's going to take the difference between the minimum return and the maximum return, and it's going to cut it up into 10 different slices. And it's going to run the solver multiple times. So we can see we've got run solver here in a loop that's going across that particular thing there. And yeah, that's going to write out to the frontier sheet. So running find frontier here then will plug data into this range here. It's just going to take what those expected returns are and plug them in here, which is what drives this particular chart. So now that we've got that configured, we should be able to just run these. Let's go ahead and do it. Config solver, I'm just going to run it to make sure that it works. I have every reason to think that it will. I'm going to go ahead and put on a different sheet active and run it again. It should activate that sheet. Yeah. And now run solver just to make sure it works independently. No errors. Looks like it did okay. So let's do this. I am going to now just come down here and run find frontier. And let's have it kind of go through that. Not sure what this is going to actually look like while it's running. So I want to be able to see what the page is doing in the background. Go find frontier, and I'll run that. Object has no title. Okay. So it looks like it's trying to change the title of the chart. Did it make a new chart? That chart. Oh, it did. It added a chart. It didn't need to add a chart. that's a bad chart. So hopefully it has much more work to do. In fact, I probably just didn't need to do that. How can I undo that? I don't think I can. So I think what I'm going to do, we could make this, add this chart, but I think that chart there will work if we just don't write over the top of it. So let me do this. I'm going to stop the code. I'm going to copy, I think the only thing I've really changed here is module 1. So let me just copy all of module 1. I'm going to put it on a notepad window just so I don't lose it. And I'm going to close this without saving and open it again. Do you want to save your changes? No. Open it. So module 1, I'm going to replace module 1 with the code that I had before. Yeah, so my code for doing the solver is all in here. Let me just go look at that find frontier. And I don't think I want to do any of this adding these charts. So let me comment that out, because I think that chart that's there is going to just be fine. We'll try it again. So I do need to configure my solver, because I opened that again, and now we'll find the frontier. Hopefully this one will do the trick. And find frontier, did I click it? Looks like it's solving. It's going through, you can see it's increasing the required return. Must have deleted the chart here somewhere. Oh, I deleted the chart here. Oh, fiddlesticks. All right, try it again. Close. Save it, don't save it. Open. Alt F11. All of this part, I'm going to comment out. Configure the solver. Check to make sure I've got a solver there. Something didn't quite seem right about that. Maybe I was editing a cell or something, I don't know. Config solver. Okay, anyone see a reason why that shouldn't be running when I run it? Try to step into it with F8. Maybe I disabled macros. Save it this time. Close it. So. Like it didn't save those two. Got the code back in. We go ahead and comment out part that's manipulating the chart. Save. Looks like it's saved. Configure the solver. At least it ran. Find the frontier. That looks better. Okay, so what did it do? It ran through, changed this, ran that 11 times with different values here. Plugged the values over here, and the chart then shows us what that frontier is. There we go. I'm not sure why we had a few of those problems, but we made it through there. Any questions? Yeah. What this efficient frontier shows is what it's showing here. It's saying, let's see, which one of these is the risk. So here's our required return here. The required return is here. So from 0 up to, not quite to 0.025. Remember that 0.024 was the highest value that we could expect to get. Like we put everything in there. To be able to get that value, I'm putting everything into Southwest Airlines. And so the full volatility of Southwest Airlines is, how volatile it is. And so the other axis here is what is my portfolio standard deviation. So this axis is the portfolio standard deviation. So what this means is that I can be anywhere on this line or to the right of this line, right? So I can find some portfolio distribution that would get me to this expected return that takes on more risk. But I don't want to be to the right. I don't want to say this is, you're taking more risk to get the same expected return. I want to be somewhere on this line. So given the amount I'm expecting, might choose to be somewhere right in here at about a 2% return. At this point, to be able to get a higher return, I'm taking on a lot more risk. This looks pretty good here. I don't want to be anywhere over here because that's risk without any benefit. So on the line is where I'm getting the most benefit for the amount of risk that I'm taking. And there's no way to get to the left of the line. There's no, this portfolio can't take me to the left of that line. So that's my understanding of the efficient frontier. Question.
So with solver, box, it's like they unrestricted, it's not negative. Like when I was recording macro, I looked at that. Nothing comes up. Is there a way to do that?
Okay, so the question is, how do we deal with this part of the solver? So how do we change, make unconstrained variables non-negative? So you checked it, you unchecked it and then checked it again?
Yeah, so I reset it and checked it. So when I went to start recording, I clicked it to deselect it, and in the recording, nothing actually.
Oh, so you deselected it. So the student here says that they deselected this and didn't see a change there. And my guess is there is a way to do it. I don't know how to do it. And so probably Google would be your friend on that one. Other questions? That's all the content I have for today. We can handle questions on the project that's due. When is it due? Tomorrow? There's no compelling reason why it should be due today. It just has to be due by the end of the semester, which is tomorrow. So why don't we make that change? Normally we have assignments due on a day that we meet so that hopefully you've like done it in time to have kind of your last questions answered here. But we can certainly adjust that one. Add a day after.
You want us to ask questions about this now?
You certainly can. Yeah. So questions about this or about the final exam or whatever. Oh, let's see. Do we have an assignment? Yeah, complete the course evaluation. So the truth is, I don't even know how you complete the course evaluation, but I'm guessing you guys do know how to do that. So, oh, you get an email? Oh, excellent. So yeah, I think there's a box that you check on there that says, you know, let my professor know that I have taken the course evaluation. So make sure you take that, and you'll get that, you know, the points for that assignment. If you do, you know, go over to rate my professor or whatever, you know, you're going to have a question mark about what are you going to do with that little chili pepper. At the moment when you're thinking about the chili pepper, you're going to go, you know, he wears the robe, and just something to think about. All right, questions, go ahead.
There's address 1 and address 2. And when I was like inspecting the elements, address 2, when there was nothing there, would like have like some of the opening, I don't know what the HTML was.
Okay, so yeah, that's like the so when you're looking for the data on that address, let me go ahead and I'm going to stop the recording here, because folks that are, you know, seeing this out on YouTube probably don't need to hear about this part.